Hello and welcome folks. Today we're going to talk about a very common interview problem on dynamic programming. You're watching Developedia, where I explain to you solutions to some very common interview problems with clear visual representations. My name is Amatya, and in this video let's talk about longest common subsequence. Alright, so let's start with the basics. Let's begin with what is a subsequence. A subsequence is a string derived from another string by removing zero or non-zero characters but preserving the relative order amongst the characters present in the original string. By that what I mean is, let's try to understand this with an example. Let's say we have a string community and we are taking out unity part out of it and we are just having com. As we can see here, we are removing some part from the string but we are maintaining the relative order of the characters in com same as community. So that's why this is a valid subsequence. What about community? In this case you can see we are removing some part mu something and we are keeping the rest of the part in here, and still we are maintaining the relative order between the characters, and that's why this is also a valid subsequence. What about this community in reverse? Definitely the order of the characters is totally reversed, and that's why the order is not preserved, and this is not a valid subsequence. What about com.im? Here the order between I and m has been reversed, so that's why this is also not a valid subsequence. Now what is a common subsequence? So if you have two different strings, you write down all the possible subsequences for each of those and you take out the commons between them. Those are the common subsequences of those two strings. In this case I haven't mentioned all the substrings because this will make the list longer and it will make the presentation complicated. So just to keep it simple, I have mentioned this 4 here, but as you can see I have mentioned AP and APL as common subsequence and the rest are not. Now what is LCS? By definition it is longest common subsequence, so it means that once you have all the common subsequences, you have to take the longest one of m, and that is your LCS. In this case, APL is the one for the strings Apple and Apollo. Now let's get back to a problem statement where it says that given two strings, find the LCS of those two strings using dynamic programming. Now pause this video for a while, think about the solution, and when you're ready, keep watching the video. And if you in case cannot figure out the solution, continue from here. Alright, so let's take an example with two strings, string 1 and string 2. String 1 being Apple and length of it n1 is 5, string 2 being Apollo and length of it n2 being 6. Now the problem in this case is to finding of LCS of n1 and n2. Now we could have just passed the strings as well, but in that case this would rise to complications in terms of memoization, so that's why we are just taking the indexes of those. And it will be more clear once you write the bottom up solution, because in case of bottom up you cannot write strings, you cannot have strings, you have to have some integers, and it's actually more space efficient, and that makes more sense basically. So that's why we are not using the full strings, we are using the last indexes. And what it means is that LCS of n1, it means that we are considering the first string of length n1 starting from the beginning. So when n1 is 5, we are considering the entire string Apple. When n1 is 4, we are considering APPL. So it means that the length of the string starting from the beginning, and same for n2. The subproblem is finding of LCS of n1 minus 1, n2 minus 1, n1 minus 1, n2, n1, n2 minus 1. And why are we choosing this kind of subproblem? It will be more clear once we take a look at the recursion. So if you take a look closely, you can see that LCS of n1 and n2, we can write it as LCS of n1 minus 1 and n2 minus 1 plus the common character once we have the element, or rather the character present on the n1th index of string 1 and n2th index of string 2 are the same. In this case, let's take an example. n1 is 4 and n2 is 5. So in that case, n1 minus 1 would be 3 and n2 minus 1 would be 4. And you can see that the characters present in these two indices are actually same, L and L. So in that case, what you do, you take out the common character, which is L, and then you apply the subproblem in the remaining part of the string, that is APP, and from here APOL. And for the second part, when you see that these two are not the same, then in that case you decrement one index of n1 and keep the n2 same and find out the LCS of them. You do the same by decrementing n2 instead of n1, and you calculate the LCS of those two substrings, and then you take out the longest of m, because you have to find out the longest common subsequence. And the last step is just to memorize, and what to memorize is basically self-explanatory, because you know that once you have n1 and n2 in your DP states, you have to memorize this in terms of n1 and n2. And what you have to memorize, it means the output of the map is going to be dependent on how are we going to devise our solution. Let's take a look at the code. Alright, so in here you can see that we are initially having two strings, str1 and str2, which is Apple and Apollo. Then to doing the DP, we are having a memo where the first part of the map, the pair of int denoting the state of the DP, which is a pair of n1 and n2, and the string we are storing as an output form is basically the LCS that we are interested in. Now n1 and n2 are the effective length of the strings str1 and str2 respectively that we are considering in the current iteration, or rather the current pass of this recursive function. And what are n1 and n2's initial value? These are basically the length of the str1 and str2, which is length of Apple is 5 and length of Apollo is 6. Now the way we write this get LCS function is, first write out the base cases. So if our effective length considerable for string 1 is 0, or the effective length considerable for string 2 is 0, then in that case we don't need to compute anything, because the common subsequence amongst nothing and everything, or rather nothing or something, is obviously nothing. So we return an empty string. Otherwise, this is the standard memo step. If we find it in memo, we return it from memo. Cool. If we don't find it, this is our recursive part. What we do? We store it in memo and then we return the result from the memo. And if in future it comes again in course of our execution, it just gets returned from the memo and it's not recomputed. Now let's take a look at the logic, what we have done in here in the recursion. So as you can see in the recursion we are doing, once we have the n1th index of string 1 and n2th index of string 2 being the same, then in that case what we can do, we just take out the common character at the last and we compute recursively the LCS of the remaining part at the beginning of it. That is exactly the same thing we are doing. We are doing the get LCS of n1 minus 1, n2 minus 1, and we are taking out the common character at the last of the LCS result. Otherwise, when these are not the same, In that case, what we are doing, we are decrementing n1 by 1 and we are decrementing n2 by 1 in the other pass, as we had mentioned in here, and we are taking the longer string that we are getting out of these two recursive functions, and we are returning the same. That's it, and we are printing it out, and that's pretty much it. Let's try running this out. Alright, APL and 3, yes. LCS of Apple and Apollo is APL and its length is 3, it's correct. Now let's do a hands-on thing. So this is a function get length of LCS, and instead of calculating the entire LCS, if we are asked to just calculate the length of the LCS, we can use this one. Of course we can do this, first find out the LCS and then do a dot length to get the LCS length. But if we are just asked to find out the LCS length, in that case we don't really need to find out the LCS itself. So we're going to use this, and this is going to be a hands-on one. Alright, so the way we're going to do is that first we're going to copy this thing, and then take a look step by step. Alright, so first take a look at this, the base case. When n1 is 0 or n2 is 0, or in other words when the effective length is 0 of either of those two strings, then we are returning an empty string. Now in this case we are returning the length of the LCS. So we're not going to return a string, we're going to return the length of the string. What is the length of an empty string? It's 0. Cool. If we find it in memo, return it from memo. The only difference being here memo is not memo but memo of length. Alright, in this one, if these two are the same, in that case what we do is, this would be memo of length, and what we are doing is that we are taking out the length plus we are appending the last character, or rather the common character. But in this case, as we are considering with length, the length of one character is 1. So we're going to write 1 in here. And the function in here is get length LCS. So we're going to replace that as well. Alright. Yeah, looks good to me. And what about the last one? Memo length. Alright. Memo of length. And alright. So if we are having two strings, and in this case we are taking out the longer string, but in this case we just have to take out the maximum length between those two strings, and we are getting the lengths in here, so we can just take out the max out of it. Alright, and let's change the name of the functions. Alright, so looks like it should work. Alright, pretty cool. It's 3. It worked. Fine. Cool. Now let's talk about the time complexity. So as I had mentioned in a previous video, the time complexity of any DP is going to be the number of DP states possible times the complexity for calculating of each DP state. As you can see here, there is no for loop or while loop in here, so therefore the complexity for computing each DP state is going to be O of 1, or constant time complexity. Now it boils down to that the complexity of this DP is going to be possible number of DP states. Now what are the possible number of DP states in here? What values can n1 take? From 0 through n1, n1 plus 1. What values can n2 take? 0 through n2. So number of possible values is n2 plus 1. So the complexity is going to be O of n1 plus 1 times O of n2 plus 1. And for sufficiently large n1 and n2, it boils down to O of n1 times n2. So that's why we have the time complexity. Now let's talk about the bottom up one. We had skipped this one in the previous knapsack video, but in this video we're going to talk about the bottom up one as well. So let's code this up. Instead of just giving you lectures on these slides or something, it would be more useful if I just do a hands-on coding for the bottom up one as well. Alright, so let's do it. First copy this part. Alright, and then let's copy this function. Let's copy the main. Alright, so we're only going to have this, and this function we're going to rewrite. Cool, that sounds good. Alright, let's start doing it. So first what we're going to do is that we're going to replicate this memo of length. So we're going to create a 2D array, or rather a 2D matrix that stores the values of DP states to the DP result at each state. So we're going to create a 2D matrix by this. Length of LCS is alright. Now what should be the size of this? The size of this should be the possible states for the DP. Now what are the possible states for this DP? n1 plus 1 times n2 plus 1, as I had mentioned before in the case of calculation of the time complexity. So therefore we're going to create this matrix to be of the dimension of n1 plus 1 cross n2 plus 1. Alright, and now once the rows is done, let's create the columns. Alright, once creation of this memo is done, let's do with a base case. So whenever we have n1 as 0, or the effective length considered for the first string as 0, or the effective length considered for the second string as 0, we return a 0. What it means is that in the bottom up one, the first row and the first column is going to be all 0. So initialize the base case. Excuse me. So for int I is equal to 0, I is less than equal to n1 I plus plus, and then we do length of LCS of I and 0, making it 0. So this we are making the first column as 0. Now let's make the first row as 0. So let's copy and paste this, and instead of I, let's make it J. I is also okay, but it looks good to use j for the columns. Alright, looks good. Now this is just the checking of memo. This is not required. Let's do this thing. Now in this step, what we're going to do, we're going to iterate until we find the result that we are looking for. In this case, the result for n1 and n2. So keep iterating until result is found. Okay, so we're going to write a for loop, which is be a nested for loop in I and j, which will range from 1 through n1 and 1 through n2 respectively. Alright, now let's do this thing. If str1 of at ith index and str2 at jth index are the same, then we add 1 to whatever we had one index less, both for str1 and str2. So if str1 of I minus 1 is equal to str2 of j minus 1, then in that case what we do is we just write length of LCS, come on, I j, this is what it is. It's basically length of LCS of I minus 1 j minus 1. So let's copy and paste this and let's make it I minus 1 and j minus 1 plus 1, otherwise we take out this thing, maximum of decrement I by 1s and decrement j by 1s. Alright, it is copied already. Come on. J is equal to max of I minus 1. It means this one, and j minus 1. Okay, so I guess we're sorted. That's it, and it looks good to me. Let's try running this. Alright, we have to return the result. Yeah, so return length of LCS of n1 and n2. Now that we have the result. Alright, so let's try running this one. Error. Alright, I plus plus has been done. It should be j plus plus. Let's try running this again. Yeah, it's 3 APL, which should be 3. Yes. Alright, so with this, thank you guys for watching. We come to the end of this video. Link to Python and C++ codes are given in the description. Subscribe to Developedia for more amazing interview problem videos. Follow Developedia on GitHub and Facebook. Catch you guys in the next one. Peace.